Allora, a questo punto intanto io vorrei ricordarvi che questo evento naturalmente è stato possibile grazie ai fantastici sponsor e organizzatori che avete conosciuto. Un po' avete conosciuto stamattina, un po' conoscerete domani, insomma, nel corso di queste 2 giornate, ed è il frutto di praticamente 2 anni di lavoro e di tanta passione, soprattutto. E quindi, detto questo, io cosa posso dire? Posso dire che aspetto sul palco il prossimo co-organizer, che è un volto che molti di voi conosceranno perché è frontman di tanti eventi italiani, ed è Diego Braga. Ciao Diego.
Buongiorno Edo, buongiorno a tutti. Grazie per
Buongiorno.
l'invito. Come va?
Buongiorno.
Vedo che sta andando tutto bene.
Sta andando molto bene, abbiamo un sacco di gente, un sacco di ospiti che guardano, che commentano. So che sei in una posizione termica impegnativa.
Ma sono seduto, quindi assolutamente sì. Allora, se sentirete la voce tremare, non è l'emozione, anche se è tanta, ma è perché sono a meno 5 gradi in questo momento che dietro di me c'è un termosifone che non è un green screen, ma dovrebbe essere un vero
Fa
termosifone, ma che non sta
arredamento.
funzionando. Esatto, quindi grazie a questa t-shirt potrò rimanere 10 minuti al massimo in call, ma cercherò di dare il mio meglio, ecco.
Infatti è giusto il tempo che hai, è
Eh,
fondamentale. Dai,
Esatto,
presentati
esatto.
un po', presenta te stesso, vai con la
Sì,
tua bio.
volentieri. Beh, io sono Diego Braga e lavoro come solution architect all'interno di Kiratech. Sono storicamente innamorato di tutto ciò che è domotica, di tutto ciò che è Internet of Things. Adesso voi vedete in generale la pubblicità di una moka che ha Alexa dentro, in realtà l'avevo già fatta 8 anni fa, ma non ci avevo creduto abbastanza. Quindi ho messo la domotica ovunque, nell'acquario, dovunque potessi e mi diverto a fare quello nell'extra time, sempre molto volentieri.
È per quello che sei al freddo adesso, perché si è rotto qualcosa.
Esatto, la domotica non è una scienza inesatta come l'informatica, quindi purtroppo devo controllare cosa ho sbagliato nel controllare il termosifone, ma se riesco ad arrivare a fine della conferenza avrò tempo di guardarlo.
Infatti. Allora,
Allora,
direi
io sono qui
che a
per
questo punto vai a
presentare
presentare il prossimo ospite, il prossimo speaker, anzi.
il prossimo speaker che è Matt Jarvis, ha una bio incredibile, quindi sono molto contento di poterlo presentare. Passerò all'inglese per introdurlo al meglio. Quindi, hi Matt, thank you for being with us.
Good
And
morning.
I'll read your bio that is really, really incredible and impressive. So I'll take the time to read it. So Matt spent more than 15 years building products and services around open source software on everything from embedded devices, and I was just saying the same. I love embedded devices, to large-scale distributed systems. Most recently, Matt has been focused on the open cloud infrastructure space and in emerging patterns for cloud-native applications. Matt is a regular speaker at conferences across the world, including Open Infrastructure Summit, the FOSDEM, and All Things Open, a past winner of the OpenStack Outstanding Community Contributor Award. And last but not the least, in 2021 was named one of the top 100 influencers in open technologies in the UK. So since Matt does only these things, Matt is also a board director of Open UK and the founder of Cloud Native Manchester and Cloud Native UK. Okay, so it's a really, really short bio, and I read just some things. Okay.
I've got lots of
Thank
grey
you.
hair, so I've been around for a while.
Yeah, just few years. And so, Matt, thank you so much for being here with us, and
Pleasure.
next the stage.
Thank you. Let's move this over here. Okay. Good morning, folks. Right, let's get this show on the road. So, yeah, that was a great introduction. Thank you very much. I'm Director of DevRel at Snyk. And the shortened version of my bio is I've been building stuff with open source for around more than 20 years, really. If you want to get in touch with me, feel free to reach out on Twitter or any of the usual places. So what we're going to be talking about today is about how most exploits in the wild, in terms of people's infrastructure getting penetrated by hackers, is a combination of application vulnerability together with infrastructure misconfiguration. And the misconfiguration allows the attacker to expand the blast radius. And we're going to look at a kind of example of this in using Kubernetes. So our starting point for this kind of thought experiment is that we found a vulnerable web application running on the internet. And we know that this web application has a remote command execution vulnerability. And for the purposes of this demo, this is a mock-up, which will just allow me to run commands using specially crafted URLs. But these do exist in the wild. I was looking at one just last week involving Tomcat. So they are relatively common. So before we go and actually start poking around with our application, let's also introduce our timeline of doom. And this is going to show us how we, over time, can expand the scope of our attack. And our timeline of doom currently just consists of our application vulnerability, which is going to allow us to run remote commands. So what can we do from here? Well, when we look at web applications in general, you know, what we often see these days is that things are running containers, and environment variables tend to be the way that we configure containers. So given that we can run commands, let's see if we can run our the environment command and see what environment variables we have. So as we can see, we can make an assumption here that we are running in Kubernetes. It's given us a lot of information about referring to a Kubernetes cluster. And so we now know that our application is running in Kubernetes. And we also know that although it's being exposed to us on port 80, it's running on port 5000 inside the cluster. We can see the service ports and various references to services here. So we can update our graphic now to show that we know we're in a Kubernetes cluster. We know we've got the internal IP of the API server that was in the environment variables, and we know that we're being the pod that this application is running in is being exposed on port 5000 internally, and it's got a service running in front of it, which is then exposing on port 80 by some unknown mechanism. Probably an ingress, but we don't know that at this point. So let's also see what we can find out about the network at this point. So if we run the IP command, we can see the IP of the pod that this is running in, and this is going to be useful to us later. So we're going to take a note of that. It's 1.7. And we'll come back to that in a little bit. So we can now again update our graphic here. We know the IP address of the pod. So let's see what else we can do. So by default, every pod in a Kubernetes cluster has a service token auto-mounted in it. And this service token is associated with the service account that was used to launch the pod, to create the pod. And you can control whether this token is auto-mounted or not by either on the service account or on the pod level by setting the auto-mount service account token to false. But let's see whether in our cluster this token is mounted. So we know where the token's going to be within our file system if it's there, and we can see we've got a token. So let's see what we can get from the internal IP address of the API server using this token. We saw in the environment variables, we know where the internal IP address of the API server is. So let's try and craft a command here let's just have a look, see what we're going to do to start with. So our first further expansion of our exploit here is that we found the pod token was available to us inside the pod. And now here's what we're going to do with that token. We're going to try and connect to the internal IP address of the API server. So let's craft a command, and we can see, we're going to see if we've got curl inside this container, which we have because we get a result here. And we're going to, because we've got the token mounted, we know we're going to have a CA cert there. And we're going to use the token to query the internal address of the API server. And we're going to try and get information out of this endpoints API. And we've got a return value here. We can see in a real cluster, this would give us the external IP address of the API server. This cluster is running on my laptop. I know where the API server is, and it's not actually going to give us that. But in a real world default cluster, this would give you the external API address of the API server. So let's update our timeline of doom again. So our pod token, in our case, allowed access to the endpoints API. So it's allowed us to gather more information about how the cluster is configured. So now we have that that token. We're going to configure our kubectl locally to access the external IP address of the API server. So we know what the external IP address is, and we're going to configure our kubectl. So I've got a little helper script here, which is going to help me do that. Let me just grab my my token again. So that's our token, and in my case, the API server is just going to be on localhost, and this is just going to create me a kubeconfig and configure it for my kubectl. So now I've got my token configured here. The first thing I'm going to do is I'm going to just see whether I can do kubectl get pods. Oh, hang on a sec. Let's just do make sure my kubeconfig is actually right. Okay, there we go. So my kubeconfig is now set up correctly. So our token from our pod here, I'm trying to get pods in the default namespace, and we can see that our token doesn't let me view pods in the default namespace, but it has given me some more interesting information. It's given me the name of the service account that this token is associated with, and the token is the service account is namespaced, and it's namespaced in this secure namespace. So let's see whether we can view anything in the secure namespace, and we can see that we can see pods in that secure namespace. So let's see what other permissions we have there. Kubectl, we can use the kubectl auth cani command, and if I do -list -token equals, and our token, oh, hang on, where's my command gone wrong there? Kubectl auth, oh, cani -list -token equals token. So this is in the default namespace, and we can see we don't have very many permissions here. We had permission to view that endpoints API, but we don't really have any more permissions than that. So let's try that command again and look at the secure namespace. And we can see here that we've got a bunch of permissions in the secure namespace. We can also, there's another way that we can view our permissions here. So we can use the access matrix plugin for kubectl, which gives us a slightly more easy to read view. If I run that in the default namespace, we can see we don't have very many permissions at all. But if I run it in the secure namespace, we can see we've got lots of permissions. Now, this is a fairly common pattern where people give service accounts permissions in their own namespace. People assuming that a namespace is like a security boundary. And it really isn't, and we'll see how we can exploit that throughout this this talk. But if we go back to our slides, we can add a bunch of stuff in here. So we know we've got a default namespace. We know we've got a secure namespace. We know that pod is running in this secure namespace. And this is the problem here, is that the service account's been given too many permissions, even in its own namespace. Someone has made the mistake here of treating the namespace like a security boundary and assuming that if we restrict that service account to its own namespace, everything will be fine. So we can update our timeline of doom here. We've got a vulnerable role that gives us too many permissions in the particular namespace. So now we know that we only have a single pod running in our secure namespace, so we can make an assumption that that is the pod running the vulnerable web application. So let's just grab that pod and let's see if we can get a shell on it. So I have got my kubectl is just an alias to K for brevity. So if you see me typing K, that's why. So let's do kexec it our pod in the secure namespace, and we're going to try and run a bash shell. And let's see what happens. Okay, so we've got a shell there, and we seem to be this web admin user. So let's just double check that. Yeah, so we are this web admin user. That's quite a good security posture. We're not running as root here. The application is running as a normal user. So let's try and see if we can elevate our privileges. We're going to run sudo su, and sudo doesn't even exist in the container. So, okay, you would think that's a fairly good security posture here. But let's see whether we can create a file. And we can actually create files here. And this is another potential vulnerability here, because if I can create files, then I can download software. I know I already have curl because I found that it was there when I tested the web application from the outside. I can change configuration potentially. And this is caused by not setting read-only root file system equals true when in our security context when we launch our pod. So and we can add this as another potential vulnerability within our container here. And as I said, it allows an attacker to potentially modify the container by downloading software or changing configuration. So let's come out of our container for the minute, and we're going to try and do something else. So now that we know we've got permissions in this secure namespace, let's try and spawn a root pod, perhaps with the root user. So I have some YAML here prepared. So let's have a look what we've got here. So my root pod YAML is going to just try and launch an Alpine image. Out the box, Alpine will run as root. So let's try and run that. So if we do kubectl apply -f demo YAMLs root pod, and we want to do that in the secure namespace. And it looks like something's happening there. So let's have a look what's actually happening in that namespace. So we can see that we've got this create container config error. So what does that mean? Well, if we do kdescribe pod root pod in the secure namespace, we'll get some more information about what that error is. And we can see what the problem is down here, that the kubelet has returned that container has run as non-root and image will run as root. So something has stopped us from running a root pod there. It's likely something like a pod security policy, but we don't know at this point. So let's just clear that. And what we're going to try and do now is run a we'll run a privileged pod, but we'll run without root. So non-root privileged. So this is going to run privileged, as we can see, but it's not going to run as the root user. It's going to run as a normal user. And since we're privileged, we're going to try and do a host mount. And with a host path here, we're going to try and mount the the root file system of the node that we're running on. And so let's try and apply that and see what happens. Demo YAMLs non-root privileged in the secure namespace. And this has given us a more interesting error message here. We know that there is a pod security policy in place on this particular namespace, and the pod security policy is set, quite rightly, to not allow us to run privileged containers. So that's good. Let's go and update the information that we know here. So we know we've got a pod security policy. It's definitely in place on this secure namespace. It may be in place other places. And so does that stop us from extending our exploit? Well, let's have a try. So let's try something else here. So I'm going to try and run a non-root, non-privileged pod, and let's just have a look at the YAML we're going to run for that. Demo YAMLs, non-root, non-privileged. So this is just going to run an image of mine. It's not going to run as root. It's not going to run privileged. So let's try and run that one. So k-apply -f. Demo YAMLs, non-root, non-privileged in the secure namespace. And this one has now run. And this one, let's just confirm that is the case. So we can see here, this is the container, the pod that we've just launched, my Snyk pod. So this is up and running. So this tells me something else here, that this cluster does not restrict me from being able to launch arbitrary images from external repositories. And clearly, we'll see in a minute why that is a good idea to not let people run random images in your cluster. And this is another vulnerability. So I know what's running in this pod because I built the image. So what I'm going to do is port forward to this pod, my Snyk pod, on port 8080 in the secure namespace. Oh, I spelled that wrong. Snyk, there we go. And now port forwarding to my new pod, and I'm going to connect to it. So I've just given myself another route into this cluster because I've now got a pod running a remote terminal. So in my pod, let's see who I am. We know we launched as non-root. So let's see here what happens when we do sudo su. And I've actually managed to elevate my privileges here to root. And this is because the pod security policy does not include allow privilege escalation equals false. So it's allowing me to escalate my privileges, in this case using the sudo command, but I could have a binary that has that flag set already that allows it to run as root. And you may think that this isn't a problem because we have other controls in place, but we'll see in a minute why that is the case. Let's just update our problems here. So this is the setting, allow privilege escalation false is not set. And I've seen lots of things, people writing about security context settings on the internet and saying, well, if I've got can't run as root and can't run privileged, then this isn't a problem because ultimately, even if you did escalate to root, you're still only getting a similar set of kernel controls as you would have if you're the normal user. But it does matter, and I'll show you why. So updating our timeline of doom here, our pod security policy did not disallow privilege escalation. So if we go back to my machine again, my pod, and I'm going to come out of root for a second. And what I'm going to do is I'm going to see what else I can do here. Let's just run ifconfig so that we've got our IP address 10.244.1.11. And what I'm going to try and do is map the network using this pod. So I'm going to run nmap. and I'm going to, I know that I had a vulnerable pod running on port 5000. So I'm going to look for port 5000 within the network, and I'm going to do 11/24. And now if I run this as a normal user, I'm going to get an error here because I don't have the kernel privileges to actually run the nmap command. But if I'm able to raise my privileges here and I run that command again, I'm now able to scan the network. And so I've actually been able to reach out beyond the boundaries of the secure namespace. And this is telling me that I have no network controls in place here that are stopping me from further exploring the network. And here we can see that is our original vulnerable pod. We noted the IP address earlier, 10.244.1.7, with our vulnerable application running on port 5000. But what I found here is another application, 10.244.1.8, and that's also running in port 5000. And that's very interesting to me, because if I had one vulnerable application running on port 5000, then I may well have another vulnerable application running on that port as well. So let's update our diagram here of what we now know. So we can see I launched my own pod in the secure namespace. I connected to it on port 8080 to give myself a remote TTY. And I've discovered this additional pod. I have no idea which namespace it's in, but it's also running a service on port 5000. So back to our custom pod again. And what I'm going to do now is I am going to construct a tunnel from my pod here to this new pod that we've just discovered. So I'm going to run socat, and I'm going to go to 10.244.1.8, and I'm going to, that's going to be on port 5000, and I'm going to represent the other end of this tunnel on this pod at port 5001. So if I create that tunnel, and now I go back to my kubectl, and now I go and change my port forward to port 5001, which will then connect via that tunnel to this new pod that we've found. So there's my port forward getting started. That's now started. So let's see what is actually on that pod. So if I now create a new, and lo and behold, we have another instance of our vulnerable web application running on a different pod. So let's get the token for this one. And let's switch our local kubectl to use this new token that we've just discovered. So if I just adjust my kubeconfig, let's just comment this one out. And let's do our new token. And let's see whether we can do kubectl get pods with this new token. And so our new token has allowed me to run the get pods command in the default namespace. So let's see what we can do with our token. Again, let's use the kubectl auth. Can I minus list minus token equals our new token in the default namespace. And we can see that this token has permissions in the default namespace. So if we now have a look what's running in the default namespace, let's see if we can get a shell onto this particular pod. So if we do kzec-it on that one, and we're going to run bin bash. So we've now got a shell on this new pod that we've just discovered, and let's see what we can do here. So no, let's not go onto this one. Actually, let's see what we can do in the default namespace. So let's update our diagram just so what we know. So we had no network controls in place, which allowed me to escape my escape the namespace and discover this pod running in a different namespace. And we created a tunnel from our sneaky pod insecure to this new pod. And we now know that that pod exists in the default namespace. So now that I've got a token with privileges in the default namespace, let's see whether I can now run a privileged pod here. So I'm going to run the non-root privilege YAML that we looked at earlier. And this token actually allows us to run that in the default namespace. So we should see that that pod is now up and running. So let's connect to this pod. Non-root priv, and let's run bin bash again. And so we've now inside our pod that's running privileged in the default namespace. So if we go to root and we look at the process table here, even though I've escalated my privileges to root, I'm still only seeing the processes that are within that container. But because our privileged container had a host path mount that I mounted the root directory of the node inside the container, what I can now do is change my root to the root folder where I mounted the host file system. And now if I run the ps command again, I'm actually seeing the process table of the node here. And we can see all of the container D processes. We would see any other pods that were running on this node. I would now have access to all of those container D instances. So let's update our slides again here. So I was able to launch a privileged pod using this new token, and I was able to mount the host file system. So our next level of our timeline of doom is that we had no restrictions in the default namespace. So now we've got our host file system. Let's see what else we can do. So we're going to look for the kubeconfig for the kubelet, which we know is running on this node. And I have kubectl on this node. So we're going to do kubectl get pods. Using the kubelet configuration, we can now see the pods that are running in the kube system. And in the kube system namespace, which is where all of the control plane runs. And I can also get the name of the nodes. So this is going to be important to us because I can now tell by doing something like this, by describing the etcd cluster pods, I can see which node this is actually running on. And that's going to be important to us in a second. We can see that the node is here, kind control plane. So, but the other important thing is let's try and run actually run a pod using the kubectl token from the node. I'm just going to try and start a busybox pod there. So I can't actually create pods directly using the kubectl token like this because of the permissions that the kubelet has. But it does say that I can create mirror pods, and this is one other attack vector that I could use. I could put YAML into etc. Kubernetes manifest on the node, and those are going to run automatically and potentially create shadow pods inside the kube system namespace. At this point, I probably own the cluster anyway. I have the kubelet token. I know where everything is. I'm in the kube system namespace. But I'm going to do one more thing here to show how we could potentially, another route that we could potentially use. So I'm going to, now I know where that etcd pod cluster is running, I'm going to come right out of here and I am going to, etcd client. I'm going to run an etcd client pod and I'm going to spawn it on a very specific node, which is the node that I know where the etcd cluster is running. And I know that I'm able to create host path mounts and also to mount those inside my pod. So I'm going to mount I'm going to set all of my etcd configuration to the etcd configuration that exists on the node. So let's run that apply-myself demo YAML's etcd client. That should be starting. That's running now. So let's see whether etcd client is configured correctly. So I'm just going to exec etcd-ctl on that pod, and we can see that it is running correctly. We're getting information back from etcd there, and etcd contains a lot of interesting information about the cluster, not least of which is secrets. So let's see whether there are any secrets in this etcd cluster. And we can see we've got a whole bunch of secrets inside etcd. And this is the one that we're particularly interested in, this cluster role aggregation controller token, because I know that this cluster role aggregation controller token has cluster admin rights. So let's see if we can get that token. So we're going to use etcd to get it, and we need to put this 2jn for... hang on. Just go that again. And there we go. We've got the token for the cluster role aggregation controller there. So let's just grab that token. We got that straight out of etcd and do kauth can I -list token equals. And what we can see here is that on cluster roles, we have the ability to update all the cluster roles. So I now effectively have a cluster admin token, and I can do whatever I like with the cluster. So let's have a look what we did here. So we created a, we know where the etcd cluster pods were running on which host. We created an etcd client pod on the same host and mounted the host path. And we got cluster admin rights from etcd. So
Matt,
it's game over at that point.
Matt, sorry to interrupt. I'm like the angel of you're running out of time.
Yeah, no worries. Well, we're basically done. We're basically done.
Okay, a couple of minutes.
Cool. Okay, so how could you have prevented this? Well, clearly, you could have scanned your application code before you deployed it into production so that you didn't have remote command execution vulnerability. You could scan your Kubernetes YAML files for security issues. It'll pick up a lot of things like permissions being too wide, like security context settings not set incorrectly. And you can scan your container images before you deploy them to look for vulnerable applications in your container images. You can do all of that with Snyk, and you can sign up for a free account at app.snyk.io. And last but by no means least, I want to give big thank yous to some folks who inspired and did lots of the hard work in terms of researching some of these issues so that I could build this demo. So thanks to Mark Manning, Ian Coldwater, Duffy Cooley, and many others in the Kubernetes security community. So I'm happy to take any questions.
Well, we don't have much time for questions. But, I'm able to only pick one. It's from Fabrizio Pandini. Are there instructions available about how to reproduce this talk and play with this locally?
Yeah, so if you this talk, all of the code for this, the setup for this is just running in kind. So you can go on my GitHub repository. I will give you the URL now. And you can see all of the setup and configuration for the demo lives there. Okay,
you should maybe just paste this link into the Bevy chat or the Q&A
yeah,
tab.
good point.
Yeah.
I'm not.
Or we can forward it for you.
Yeah, that'd be great. I'm not currently in the Bevy chat, so
yeah, no problem. Just one more. Is this the same on all Kubernetes platforms?
No, I mean, that's a good point. I mean, your mileage does vary with some of these things, right? Particularly, if you're all of the vendors will have their own kind of opinionated settings about security. If you run on OpenShift, a lot of these things are set for you by default. And if you run in the cloud providers, obviously you have different security settings depending on which managed service you're using. I think that's the important thing when we think about Kubernetes security. Lots of people say, "Oh, Kubernetes is really insecure," but Kubernetes, the upstream vanilla Kubernetes is designed for maximum flexibility, right? So there are no guardrails. So you need to understand how to configure this stuff when you deploy it, if you are deploying from scratch. But yes, if you're using a managed service provider, they're going to have their own set of things that they're probably going to set for you. So you may not be vulnerable to all of the things that I described in this talk.
Yeah, and how can I protect myself?
Yeah, like I said, I mean, scanning. I think getting your mindset into scanning stuff before you deploy it. So, I work for Snyk. You can do all these things with Snyk, but other security tools are available in the Kubernetes in the cloud native ecosystem. But scanning your Kubernetes configuration, all your YAML files before you put them into production. Scanning your applications to make sure your applications are secure. They don't have vulnerabilities that you've brought in through dependent libraries you're using or whatever. But building security into your workflows is really the key to this. And I think we're getting a lot better at understanding that. There's lots of great material out there from the Kubernetes security community and from the CNCF security community that you can read up and learn about how to go about security in a cloud native kind of way.
Okay, thank you, Matt. It was really an amazing talk, and you also have quite the background behind you. It's almost like a virtual background.
It's my new office, actually. I've just moved in, so what you can't see is all the boxes over this side. I'm still unpacking.
It's really amazing. Well, I'm trying to buy some time actually to see if some questions come from the chat, but nothing. We have nothing. Well, if you want, you can stay with us and maybe check the chat.
Yeah, I'll go and hang out in the chat for a bit. If anybody's got any other questions, feel free to hit me up there. That's cool.
Okay, thank you very much, Matt.
Pleasure.
Bye. Ciao.
Bye.
Ciao.